Hello and welcome to your second All the Things You Need to Know lecture. This one is going to be about some of the Python things that you need to know. And some of these things might be things that you're already familiar with, but a lot of this will be new since we're working with a new library that we don't cover in 230 or any of our other classes called Pandas. So the first thing that I'm of course going to do is load all of my libraries. So let's run that. Okay, now that that's done, let's talk about data frames and how to create them, because there's multiple ways to create or import data into your script or your notebook, and I want to cover a few of them. Just before we start doing that, I covered it a little while ago in the other lecture, but a data frame is basically the Python version of an Excel spreadsheet, just one sheet. It contains rows and columns, and that's how we like to think about data, and we're going to refer to those throughout the entire class as a data frame. Okay, so one way we can make a data frame is if we have lists for every single column that we want in our data frame. So let's say that we have a variable called name, and inside of it we're going to put a list with Tom, Jane, and Alice. And then let's say we want their age, and we'll have that as a list of integers, let's say 20, 21, and 19. And then lastly, we're going to have what their major is. And let's say we have, business, data analytics, and business. So if I have a list for every single column that I want in my data frame, I can make a data frame by putting those lists as objects in a dictionary. So we'll call this 2df, and we're going to say equals, and we'll say name, so the key in the dictionary equals name, the list of names, age is age, and we'll say major is major. I just want to point out, I'm sure you already know, but you don't have to call the key name the same thing as the variable name that holds the column. I'm just doing that because they're really great descriptors here, but just FYI, you don't need to. You could call this final, major, or something like that. It really doesn't matter. Okay, so now that we have a dictionary, we can use the pandas package, and we can say df equals pd dot data frame, capitalized, and then give it our dictionary as an argument. So we'll call 2df. So when we create this, this is creating a pandas data frame, which is the way that we're going to work with most of our data. So if you ever want to see just a little bit of your data frame, you can of course print out the entire thing, but typically data frames are pretty big. If you just want to see a little bit of your data, you can say data frame, whatever the name of the data frame is, dot head. Oops, got to spell that correctly. And then that will show you the first couple rows of your data frame so you can make sure that everything looks good. Let's go ahead and run this here. Cool, so you can see our data frame looks hopefully exactly like you think it would. We have 3 columns, name, age, and major, and all of the data that we entered in. The second way that you might have data in terms of Python objects is if you have a list of lists, and each of the sublists has a row of data. So to create the same data frame that we did before, we can create a list of lists, with each row being a list. So we'll say first Tom, not Tome, Tom, and then his age, which is 20, and then his major, which is business, and then our second sublist will be Jane, who's 21, and is a data analytics major. And finally, we have a sublist with Alice, who is 19 and is a business major. So when we have this list of lists format, the way that we make our data frame is actually almost exactly the same. We're going to call it df2 equals pd.dataframe. And we're going to give it to df2, so we're going to give it our list of lists. But the only thing that we need to do here is, because it's a list of lists and not dictionaries, we don't know what the column names are. So we could leave it blank, but that's going to be confusing. In order to tell pandas what we want the column names to be, all we do is add the argument columns equals, and then we give it a list of the column names. So again, here it'll be name, age, having capitalization trouble, and major. And when we look at the first couple rows of this, it should be exactly the same as our other data frame, because we created the same data frame just in a slightly different way. So let's run this. Beautiful. And you can see exactly the same data frame, just a different way to create it. Another way to load in data instead of creating it that already exists is by using a URL for wherever the data is located. And this is pretty much one of the most common ways that we're going to load in data. And I want to show you something from our class GitHub page really quickly. So if you look at our class GitHub page, you'll see that there's a file called data, and this contains a huge number of the data sets that we're going to be using and working with together. When you click on this, you're going to see a bunch of files, and let's say that we want to open, let's say that we want to open ramen ratings. So when you load a data set, you're going to see a button up here at the top right that says raw. If you click on that, the URL that's generated here, you can copy and paste and directly read that with the pd.read_CSV function, which is what we're going to do right here. So I'll call this df3, and we're going to say pd.read_CSV. And then you're just going to give it a URL as a string. So here we've stored it as URL df. You could also directly put the string in here, but this basically allows us to directly load data from the internet, usually from GitHub, but from any page that has the raw data on it. So let's go ahead and look at the head of this. And here you can see this is a data set about diamonds and their clarity and their cut and etc. And you can see that we've loaded in the content straight from this URL. So this is another and one of the most common ways we'll use data. Similarly, you can load in data from a file on your computer. So instead of it being on the internet, it's on your computer, but the idea is almost exactly the same. So we'll say df4 equals pd.read_CSV, and then you're going to give it a string that is the file path to your data. Now here we've stored it in path df. You can also give it just the raw path string here. And let's see what this is. So we'll say df4.head. Okay, and let's run this. So I've loaded this exactly from my computer instead of from the internet, but you can see that it is exactly the same as loading a URL. You're just changing what's in the string. Now that we've loaded some data, we have to think about, well, what do we want to do with it? One thing that we might want to really commonly do is just check out our data, see what it looks like, see how many rows it has, how many columns it has, and get a little bit more of an intuitive idea of what we're working with. The first thing that you're often going to want to do is say dataframe.shape. And this is going to print out the number of rows and columns in your data frame. So rows first, then columns. So the current data frame that we're looking at, which is a penguin data set, is 344 rows with 9 columns. And if you count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, you can see that that's accurate. Other thing that you might want to do is see what the column names are. We talked a little bit about this in the debugging lecture because often there are weird things happening with column names when you're downloading data that isn't something that you created. And to do that, we use the .columns function. And so we'll say columns, the .columns attribute. And what this will do is it'll print out the names of all of the columns in our data frame. This is really useful, making sure there's no weird spaces, new lines, weird extra characters, and just giving you an idea of what's actually in your data set. Now that we know a little bit about the structure of our data set, we might want to look at the actual data inside. One thing that's really important to do is if you use the .info function, this is going to give you a little bit of information about all of the columns in your data set. For instance, you can see how many data points there are. At maximum, we're going to have 344, but you can see some of these variables are missing values for different rows. Another really great thing here is that you can see the object type for that column. So if you have a float, you'll be able to tell if it's a float. If it's an integer, you'll be able to tell if it's an integer, and so on and so forth. Another way to look at some information about your data frame is to use the data frame for .describe function. And this is going to give you essentially a summary of all of your data, at least the continuous variables. So here you can see that for the continuous variables that we have how many are there. So there may be some missing, for instance, flipper length and body mass and build depth and build length. Actually, most of these are missing at least 2 values. Then we have the mean, the standard deviation, the minimum, all of the quartiles, and the maximum value. And this is a really great way to check to make sure your data looks like you think it does. Are there values that are really extreme that you didn't expect? Is the mean a number that you would expect? Are there more missing values than you would expect? All of these things, at least for continuous variables, can be done using the describe function. And then of course, as I already showed you, we have our trusty df.head. And if you just run this function, it'll show you the first couple of rows, but you can actually specify how many rows you want to see. So say we have the need to see 12 of our rows, we can run this and it will show us the first 12 rows of our data frame. So we already saw some ways that you can check for missing values. If you want to explicitly check for missing values, you can use the .isNull function on your data frame. So we can say df for .isNull, which checks if values are null, aka missing. And then we're going to use the .sum function to give us a summary. So the isNull function tells us whether each cell is null. The sum function tells us how many missing values there are. So when we run this, we can see for each column in our data set how many values are missing. It looks like a couple of the measurements are missing 2, and then the sex of the different penguins is missing for 11 of our rows. Not bad for a data set that has 344 rows. Now, having an entire data set is really useful, but sometimes we need to look at only part of it. For instance, we might want to look at just one column of our data frame. Let's say we want to look at species. One way to do that is to say the name of the data frame, square brackets, and then a string that says the name of the column that we'd like to look at. When you do that here, you can see that it's giving us the species of all of the penguins that we're looking at as a vector. This is also really useful if you want to grab the mean of something. So let's say df4 bracket bill length. And then, so again, here, let me show you what this will do. So if you do this, this will grab all of the bill lengths of all of the penguins in our data set. And we can use the .mean function to get the mean bill length. So it's 43.92. What a great bill length. We also saw this information when we used the describe function, but if you ever need to pull a specific column mean, this is how you can do it. Now that we've talked about doing individual columns, let's talk a little bit about pulling individual rows. So say df4 that we would like to see just one certain row of our data frame. We can use the .iloc function, and we can give it a integer. And the integer says which row that we want. So in this case, we're getting row 8. And when we run this, you can see that it'll give us all of the information for that row. So the species, the island, the bill length, bill depth, etc., all from that row. If for some reason you want this information as a little tiny data frame instead of as a series, which is what this is, just add inner square brackets, so that's 2 brackets, and you'll go ahead and get just the one row as a data frame instead of as a series. You're also able to use the iloc, which by the way stands for integer, the I in iloc. You can also use this to grab a couple rows if you want. So we can say df4 dot iloc 2 through 7. And when we run this, you can see it gives us the 2, 3, 4, 5, 6 row, and we can grab just a subset of our rows through this iloc function. Oftentimes when we look at data, we're only going to want to look at certain rows, but we maybe don't know exactly what the indices of those rows are to use with the iloc function. In order to do this, for instance, let's say we only want penguins that are from the Torgerson Island. Well, we can do that using the loc function. The loc function can take a list of booleans, so true, false values, in order to give us only certain rows of our data frame. So let's create a variable called torg, which is going to be a true false value for whether or not a penguin is from the Torgerson Island. So to create this list of booleans, we're going to say df4 bracket island double equal, so this is checking for equality, the string Torgerson. There we go. Let me just show you what this looks like really quickly. Awesome, so you can see that we now have a vector or a list of booleans true when the specific row is about a penguin from Torgerson and false when it is not. Once we have this stored in our variable torg, we can say df4.loc bracket and then torg. And this will give us a data frame of only the rows that have penguins from Torgerson. Awesome, so you can see that this is what happens. It's a very long data frame, but it exists and we now have it. Similarly, we can grab our data frame rows based on a continuous value. So for instance, let's create a variable and we're gonna say df4 bracket bill length mm. And we're going to say we only want the penguins whose bill length is very short. So let's scroll up here. So let's see, bill length, let's say short will be smaller than 39. So we'll say any of them that are shorter than 39, grab those. I'd like to see them short-billed boys. So go ahead and we can do that. And I'm actually just going to show you what this Boolean vector looks like. Awesome, so you can see another similar Boolean vector where only the penguins with short bill lengths are selected. And again, we can say df4 bracket, df4.loc bracket short boy. And this will give us a data frame with only the penguins who have very short bill length. Similarly, we might want to filter on more than one column. So in the last time, we had a filter for bill length, but let's say that we want a filter on both bill length and bill depth. So we only want penguins who have very tiny bills, both in length and depth. So we're going to create another Boolean vector, and this time, instead of just using the bill length, we're going to add bill depth. So I'm going to go ahead and copy and paste this, and let's put it in parentheses to make sure we get everything nice and neat. But now what we can do is use the AND operator in order to create another second condition that needs to be true if we're going to select a certain row. So just like we did before, we're going to say df4 bracket bill depth mm. And we'll say is less than 18 because it looks like most of these are pretty big. So if it's less than 18, we'll consider this a very short bill. So let me go ahead and print this out so you can see what it looks like, and then we'll use it to subset our data frame. Awesome, so you can see it's another Boolean vector, so these are going to be penguins that just have short bills, both in length and depth, if there are any in our data set. So to do this in subset, we're going to say df4.loc bracket short boy 2, and let's see how many penguins there are that just have very, very tiny bills. Awesome. Okay, so we can see that these are all the rows that have very short bill length and bill depth. So now that we've done that, let's go ahead and try and use the skills that we've learned in order to answer a question about the data. So say I'm still interested in these penguins with very short bills, both in length and depth. I want to know what their mean body mass is. Well, I can totally do that. We're going to use this short boy Boolean that we did before, and again working with our df4 data frame. So we'll say df4.loc bracket short boy 2. And what happens here is that we are going to specify a certain column. So before, when we were just doing it like this, we were saying give us the entire data frame, every single column. When we add another argument, we're going to give it a column name, and this is basically going to return to us the subset of data frame, but only the column that we've specified. So in this case, we're interested in body, mass, and grams. And let's actually just print this out and see what it looks like. Awesome, so you can see we've got a vector of all the body masses in grams. These are very hefty penguins. And if we want to know the mean weight of all of these penguins, let's go ahead and use the .mean function. When we run this, this will give us the mean body mass of all of these penguins that have very short bills. So here it's 3,335 grams, which is a lot of grams, but it is an entire penguin. Awesome. Hopefully this gave you a little bit more confidence working with Pandas data frames. There's going to be more things that we're going to learn throughout the entire semester, but hopefully this lecture sets you up for success, at least at the beginning. I will see you next time.